kindly ask to use these dedicated slots to raise your hands and ask any questions you want, because we will have different presenters and we wouldn't like to interrupt them. I would also kindly ask all of you to mute your microphone so we don't have any echo. Oh, okay, thank you very much. Can we move to the next slide, please? Okay, so regarding the workshop practicalities, I already said that you're all kindly asked to mute your microphones. You can use your chat. And we would like to ask for approval for recording this webinar. Okay, we are going to move with the intro. Can we go to the next slide, please? So just to give you an idea what has happened, we have last year we had could you please mute your microphone, Maya? Thank you. Last year we had the first style guide webinar at the 26th of January, where we introduced the idea of the SEMIC style guide. And we presented the main topics, and we had the Q&A discussions to see what was the feedback and what was the working group and our audience thought about this idea. And then at 19th of April, we had the final review of the SEMIC style guide, where we discussed the change log, and we had a plenary discussion, and we explored what was going to come next. Next slide, please. So what happened from that time until now? During that webinar, we discussed about how people could validate the semantic models against the rules that we provide through the SEMIC style guide. And we managed to create an automatic validator that validates semantic models against the style guide rules. And this validator is now integrated into the ITB, the test bed. And you can find, in case you don't know, you can find the link in the chat. During our discussions in the previous webinar, we identified various topics of interest, and we would like to delve deeper into them and get also your feedback. So we also wrote a blog article on application profile development, which will be mainly discussed during this this webinar. So today we would like to engage with our audience and get feedback. This feedback is going to be considered for the update of the style guide that we have foreseen for this year. And also we are going to have a look at the topic of our next blog post, which will be RDF-based conceptual models. So this is what's going to follow. And at this point, I would like to give the floor to my colleague Eugene. Thank you.
Thank you, Natasha, for this comprehensive introduction. I think we can just dive into part one, so that the table is set now. Let's look at part one, which is about development of application profiles. So how do we approach that? And we decided to avoid any abstract discussions and choose a very concrete specific case, and that is the case of DCAT-AP. We took it as an example, so it will be like a silver line thread, but the topic, it's not a DCAT-AP webinar, it is a webinar about application profiles. So that's to emphasize from the very beginning. So let's move on. I will present the challenges, because a big part of the discussion that we want to trigger today is around challenges. What sort of problems do we solve or need to be solved when we are building, when we develop an application profile. And then it's also important to expose a bit or to give a hint on what are the approaches. So that's why we will present the challenges first, then Jakub will present the Czech application profile or the approach to developing the Czech application profile of DCAT-AP. Then Matthias will bring a Swedish perspective on how application profiles are approached there. And we will expose at the end of part one the SEMIC approach to building application profiles. Okay, so then we'll have a little discussion afterwards. Okay, so there are 6 challenges that I will expose now, but they're not the only ones, in fact. But I think it's a good starting point to address. So the challenge number 1 is about vocabularies. So when the vocabularies are published and when they are created, more often than not, they come with an application profile, with an implicit application profile, but then that is not, stated like how it should be interpreted. So for example, when we have cardinality restrictions in diagrams or domain and range specifications, sometimes the interpretation of this are not explicitly said. It's prescriptive or descriptive, or it's just for consultation. It's not provided. So we need to figure out how to go about that, or at least accept that there is an implicit one and it should be done implicit. There's an implicit application profile and we should make it explicit. Let's go to challenge number 2. So challenge number 2 is, well, first of all, before I explain the challenge number 2, I think I hope we all accept this idea that when we are creating a data specification, this data specification is it's not just one artifact, only the OWL or only the HTML, this documentation, or only the shackle shapes. It's a set of different artifacts. So if we accept the idea that a data specification is comprised of multiple artifacts that need to be synchronized, they need to express the same thing in a harmonious way, then there are 2 challenges about this. And one of them is that the data specifications, when they are published, there's no consistent set of artifacts that is published with each data set, with each data specification. So for example, DCT publishes the HTML documentation in OWL or RDFS representation. In DCAT, we have the same and UML diagrams in addition to that. In DCAT-AP, we have shackle shapes in addition. So the set of artifacts is not consistent. And I think it's important to know which aspects are explicit and which aspects are implicit. And the second one is that when these artifacts are published, depending how they are maintained, if they are manually maintained, then it means that the editors have to edit. If there is a change somewhere, the editors have to change to propagate that change throughout all the artifacts, and that is a source of errors. So synchronization of data specifications across artifacts, hopefully in an automated manner, is another challenge that needs to be addressed when data specifications are developed. Let's move on. The third challenge is about expressing relationships between application profiles. So we have identified, this is not an exhaustive description, but we have identified these three cases which are most often or often occur. So let's say a proper profile over a vocabulary. So if we look at the middle of the green circle, reused vocabularies or AP, then if we want to do an application profile on top of that vocabulary, we have to come with an set of constraints to extend it and to bring compatible constraints on top of this vocabulary. But not always. We don't always need to reuse all the terms defined in the vocabulary. Sometimes we can use just a part of it. So we see in the middle that the new application profile only reuses some elements, and hopefully this reuse is congruent with the what the definitions of in the vocabulary or of the reused application profile. But sometimes we have this reuse of some elements from another vocabulary and application profile, and then sometimes there are non-compatible constraints. There are constraints that are overwriting in a way, or changing the initial definition, or extending in a way that it's not really foreseen, or yeah, they're not well aligned. So that's a problem. Actually, that's challenge number 4. Let's we address it in the next here, yeah, in the next slide. Let's stay on challenge number 4, where sometimes the extending application profile is not coherent with the reused one, and then what are we to do about that? That's an open question, because we saw this as a practice, and sometimes it does occur, and yeah, we need your feedback on if you have such situations, how did you solve it? How do you go about it? Basically, how can we ensure that, for example, our RDF representation of DCAT is compatible with that from DCAT-AP, or the shackle constraints are compatible. Okay, let's move on to challenge number 5. So in the style guide, when we are defining reuse, in fact, the previous 3 challenges are around the concept of reuse, in fact. So in the style guide, we decided to address in detail what does the reuse mean, how to go about it in different situations. I hope we can extend that section in the next iteration, or actually we welcome based on your feedback. And one of the ways in which we reuse is that when the extension is created, sometimes a need arises for extension through specialization. Sometimes the need arises to specialize either the vocabulary defined in the reused data data specification, or by extending. So basically we specialize either the vocabulary or the constraints or the shackle shapes of the reused artifact. So they're safe in a way. This mechanism is safe to use subclasses, subproperties is safe, but they proliferate. They proliferate definitions of new terms, and we wonder how much does this affect interoperability, if at all, and how often shall we use this method. Basically, at the end of the day, we want to ensure a smooth interoperability and ease of implementation. So that's another open question. let's move on to the next and the last slide of listing our challenges. So the concept of entity profiles emerged from the working from the community, and a call has been made to decide how do we specify them, what do they mean, how do we designate them, how do we define them formally or informally, and yeah, because entity profiles are nothing else but, you know, guidelines or definitions of how a class is, or a property is to be used, or how a class is to be instantiated. So and also brings to the table the idea that a class or a property can have multiple profiles, just the way we have in mind the idea that there can be multiple application profiles for the same vocabulary. Okay, so this is a very quick overview, run through actually the challenges. On the next slide, I propose to open the discussion about the challenges, and here we invite you to comment, share your experience, ask questions, yeah, about what, yeah, how did we encounter them, or share how did you go about solving them? So we invite you also to write down questions in the chat, or you can just raise your hand and speak.
I saw that Matthias Grunewald already has 2 contributions related to it. So maybe if Matthias.
Yes, I can comment on it if you want.
Yes, that would be great.
Yeah, thanks for the opportunity. So I just want to raise the point that improper subclassing was stated as a very safe form of proliferating constraints or proliferating semantics. I want to point out that improper subclassing, so the situation that highly specific subclass for a very specific purpose are introduced into vocabularies or into profiles without the actual need for them or without the wider perspective are often a reason, in my experience, for the later improper reuse. So I would not deem specific or highly specific subclasses the safest way of well describing semantics in profiles, but just like raise this point that this might be an issue, but overall I would agree.
Is there anyone who wants to complement this or has additional feedback?
I'm Matthias here. Do you hear me?
Yes.
Yeah, so the other Matthias. I agree with what Mr. Granwald just said. Very good. I had a comment on the relationship between application profiles. I think we should consider that you can base an application profile on another application profile, even though there are incompatibilities. Like your DCAT-AP is an extension some way, like it's based on DCAT-AP, even though it is not compatible all the way. So maybe there should be different kind of reuse, like a pure reuse, which is always in line with everything that is said, or based on largely the same. I don't know more about this. I'm just feeling that this is the case we have.
Indeed, we listed this as an example under challenge 4. I think mobility DCAT-AP has also an exception to it when extends the DCAT-AP, and I think it's good to again write. I mean, if you can share with us your examples, and we can to consider what should we input, what else shall we put in the style guide, right? because
yeah, but I think it's something to the community around the table to take up the question from Matthias, or what he raised is how we do the community as well see the need for getting an insight in the interrelationship between profiles. So Matthias raised this, that there's a potential conflicting or fully agreeing and so on. So this is some aspect, some qualification between that. Do we have to make this more visible and to have to put more agreements onto it? The question.
Also, to complement this further, there might be an interest to state that an entire application profile is an extension of another application profile. But individual parts, like the dataset of a DCAT dataset, is the same, but the distribution level is that we have a constraint difference. So, yeah, do we need to express the relationship very much more fine-grained? And then we need to have a way of referring to individual parts inside of the application profile as well.
Yeah, Matthias, you were also hinting at the solution, possible solution already using
Shackle shapes, yes.
shackle shapes and prop vocabulary.
Yes. We'll show a little bit about that later.
It's coming.
Matthias Grunewald, I'll give you the floor.
Thank you. I don't know about Matthias' solution, but I would suggest something similar. So I also feel that this the way to combine profiles in a correct fashion, to say, is by importing into shackle shapes, basically cascading modules of profiles into each other, and defining a best practice on how to transform semantics via, because shackle nodes inherently don't carry any semantics, they just like extend. But there's work on this, and I feel this is the best way to do this, and the style guide should cover best practices on how to avoid semantically incompatible or interoperable, like not interoperable constraints. So I think it's on a technical level possible to create those, but it's in the responsibility of the user creating and recombining profiles to prevent this. And I think this is a general best practice in semantics or in ontology building or everything, that it's your responsibility as the person defining a new profile or creating an ontology to make sure that reuse is not conflicting with the original definition, else reuse is not possible. And this should be covered in style guide as well. So, but overall, I think this is the way to go. Building in a DCAT-AP sense, modules, profiles that could be reused into more specific or into more into shapes with a different scope. So, for example, having like general entity shapes for DCAT-AP that can be reused in more specific DCAT-AP sub-profiles in a sense like GeoDCAT or what there is to come.
Okay, I think to a large extent we already covered this in the style guides. So to make this responsibility of the editor or the specification in the reuse guidelines. So you pointed it, and one element that you put in the chat that you say put let's say that constraints are part of let's say more adaptable or safer to reuse. One aspect to be added into it is that in the context of the style guide, we as well included the definitions, the textual definitions as part of the constraints, so that you don't lose that into it.
Yes, I would agree.
But that actually opens up a little bit broader discussion on the use of labels, or how the labels and definitions, what do they mean, what purpose they serve, because there's one set of definitions that comes in the vocabulary, and then when the application profile is created, often the application context imposes or asks for slight adaptation of the labels because either because the context is such that the other labels fit better, or because the users want to use it for directly in applications. So to have like a visual display, or like to have like fields denotating fields. So I think reuse with lexical adaptations also should be taken with a grain of salt, and we should know what is the purpose of changing those things. What about vocabularies with an implicit application profile? So sometimes I've seen some standards being published, and they come with a beautiful diagram. Yeah, the diagram shows, most of the time it's an UML diagram showing classes, relations between them. But then they want to stop, or the editors of the authors of that stops at the defining just the terminology, URIs, which is great. And then sometimes we look at this diagram and we have a feeling that, there is a domain and range, for example, implied from those diagrams, but nowhere it appears as being defined. So what do you think about these implicit application profiles? Come somehow unintended, they appear on the table. Anyone has an opinion on that, or had issues on that with that sort of vocabularies? Yes, Matthias.
I would just like to say that we should lead the way here and make it obvious for other people in the wider standards community that, okay, there is a way of doing this. If we develop a way of doing this here, we can suggest for others that perhaps make this clear when you write specifications. So when there is a next update to DCAT, they will take this into consideration and make it more clear. I don't think we can. So a general guidance would be that yes, there are application profiles here. We just make sure everyone understands it, and then for the future they will be more clearly expressed.
So, for example, for Matthias Grunewald, is that if you look to DCAT as W3C is defined, then you sometimes have the challenge that over some aspects, it is a vocabulary, just a list of a namespace with terminology, whereas some elements, like you should use best this controlled vocabulary, so this code list, or it must be this, becomes closer to an application profile. And the question is this part of the definition of the term, or is this part of the harmonization effort you want to achieve through DCAT? Minimal implicit application profile.
There was another comment from Alberto. Do you want to bring it up?
Yeah, if you wish. So you know that I'm running an agile standardization initiative, and our solution, which is, let's say, working, is that we have a single source of truth for all the semantics that we compile. In our case, we use JSON schema because we want the usual people to contribute. And everything that we have, every artifacts, like the specifications, exports in different formats are done, everything is done automatically. So once we approve a new version, it takes around 10 minutes to have everything updated. And I really recommend, and the source code for this, for the specifications, I shared into the chat, and this source code is capable of taking the JSON schema, the descriptions and the data types, create a markdown specification and translate it into 7 languages.
Thank you, Alberto. So is there anyone around the table that wants to contribute on saying, okay, this is an additional challenge, or some of these challenges that we put up here on the slide, that we would share some experience or some attention focus upon?
Rita has her hand raised.
Has she raised? Because yeah, I'm maybe overlooking it. Then Rita, yes.
Yes. Yes, hello. Yes, I just continue with what Alberto said about single source of truth. So that he said that they have JSON and we have all specifications. So that, for example, I think that when you look, for example, SEMIC style guide, and there is the headline data specification and artifact types. Under that, you say that you start with conceptual model in UML. But our conceptual model is in OL2, and all the rest of that table we do like there are. But the point is that the starting point from our starting point is from OL2. But my point was that what Alberto said, that when we have a single source of truth, we can produce all the other artifacts from that single source, for example, shackle shapes and HTML descriptions and also model diagrams. So that the idea is that there's no inconsistencies between the different artifacts because you generate them from one source.
Yeah.
So,
are there, Rita, in your case, are there any of the cross-profile challenges or reuse challenges that we list here? So, for instance, is there a need for a finer-grained entity profile specification, or do you how do you treat all the any challenges between application profiles and vocabularies, or application profiles between each other, that you would like to additionally raise here?
I don't think we have that kind of problems because, well, in principle, when you are creating something like the core vocabulary, and then if the application profiles use that, and they all have information from what source they have been derived from, because they all have URI addresses and so on, so that we can see if there are, if the specifications are created in that application profile, or if they are derived from the actual data model. So that I think that you can see the source of the data, and you in that way you see the inconsistencies, but it's not in principle it's not possible to have a description that seems to be same but is different, because you see from the ID that they are not the same.
Okay, thank you for your feedback. I just followed the next on lists. Here, Thijs.
I have a question or a concern maybe with the specifications of vocabularies. Often we find that when reusing a vocabulary, that it's actually a bit over specified. And for example, there's a certain range for a property, and in the application profile, we would like to use another range, maybe a more specified, more specific data type or something. And but we still want to reuse this term. So we do this by adding a constraint to the shackle specification. There we specify another data type which suits our purposes better. But then, of course, your data will only validate against the shackle and not against the vocabulary anymore. So that's a real challenge, because some vocabularies, they are rather loosely specified, and others are very specific in range and possible data types and so on. Some are very closed world, where it's not suitable to reuse. For example, geometry, which is specified within this closed system, while everybody wants to use, for example, GeoSparkle or something, yeah, for geometries. What we do then is we re-specify with a constraint in the shackle.
You're in that situation defined by challenge number 4. How do we ensure the coherence? And sometimes when we can't be coherent 100%, you have to find your way around with saying which constraints are contradicting, let's say, the reused vocabulary, right?
And I don't know how it's possible to ensure the coherence because we use a lot of vocabularies from different sources, and they are very useful. The definitions are very useful. And for example, they are specified by the ISO, the International Standards Organization, and they are or by Inspire, and they are very useful. But they don't have the correct data type, or they are already rather old, and the definition is perfect. And we want to reuse the URI, but we don't want to use the data type. So coherence is very difficult to achieve, I think, there.
Okay, I think this is a good point to list. I only want to give, for the time being, Ansi still the word. And Matthias, sorry, you can have an additional and then we will later.
Yes, thank you. Just continuing Rita's answer a little bit from the Finnish open data perspective. So as Rita said, we didn't encounter any challenges regarding the vocabularies themselves when we were doing the Finnish open data DCAT-AP profile. But since we sort of like introduced the DCAT-AP profile into a world that was already ready, and it was ready-made and it had its own practices, we couldn't use all the classes and subclasses, and especially the optional attributes as they were. And that, I think, is kind of like what led us to the situation that was just mentioned in one of the previous comments, that also our DCAT-AP in parts validates only against our own shackle, but not necessarily against all the parts of the current DCAT-AP2 implementation. It looks like the DCAT-AP3, when it's coming, will alleviate some of the issues that we have. But yeah, I would say that, you know, we had a fairly common problem in that sense.
Thank you for the feedback, Ansi. So I think now we move on to the next. We have lots of things ahead still. I want to give the vote sufficient time to it.
So let's move on.
Are we doing a break now? Or
next slide? Yeah, after. Okay.
It's a break.
So
yeah, Eugene, you go ahead.
Well, we decided to invite for an early break now because it makes sense to keep the 3 presentations together before our next discussion. So let's meet in 5 minutes, 5 minutes.
Yeah, so
it's 43.
43, let's say 46, something like this, to stretch a leg shortly and then continue.
Yes. Okay,
Yes, let's go.
let's move on. Trevor, if you change the slide, please. So what we have next are two invited speakers. First will be Jakub and then Matthias, presenting different approaches to building application profiles, and then we'll do the we'll present the approach taken in SEMIC. So Jakub, do you want to take the floor?
Yes, thank you. Good afternoon. I will shortly talk about the experience of creating an application profile of DCAT-AP for Czechia. In Czechia, we run a national open data catalog, as is the case in many other states and countries. The content of the catalog is governed by DCAT-AP, of course, but we needed some tweaks. Hence, we created a Czech application profile of DCAT-AP. And let me start with stating the purposes of creating an application profile, because these are a little bit different, or maybe there is one in addition or two in addition to the purpose of DCAT-AP. So the first purpose of creating a Czech national application profile is description of what the Czech national catalog actually harvests from local catalogs. So this purpose is similar to DCAT-AP, as in DCAT-AP we have a description of what the European data portal harvests from the national ones. So this part is the same. There is a second purpose, and that is also to specify an API of those local data catalogs, which is in addition to the purposes of DCAT-AP itself. So we specify that either we take compliant DCAT-AP CZ records from a SPARQL endpoint, or there is a mechanism of publishing those DCAT-AP compliant documents on the web as a set of files, basically. But we go into a technical detail because we are closer to the actual systems implementing that particular application profile. And then this application profile serves as well as a documentation of the contents of the SPARQL endpoint containing all the metadata records in the Czech National Open Data Portal. So those are the three purposes of the Czech application profile. Now, let's have a look at the profiling techniques that we use to create such a profile. So we took DCAT-AP, and we needed to do some things to create the Czech application profile. One of those things is localization. So quite obviously, we needed Czech labels for all those things that we wanted to work with. And it would be unfeasible, let's say, to do this via, let's say, pull requests to all the reused vocabularies such as FOAF, Dublin Core, or DCAT itself. There are many of them, and it is not possible to localize all of them and push the localization strings there and wait for them to be accepted and so on before we use them. So the first thing is localization. Then scoping. We didn't need all that DCAT-AP offers. We only needed a subset, so we needed to specify which is the subset of classes and properties that we use. And then we needed to extend DCAT-AP with some Czech-specific things like usage of Eurovoc for additional dataset themes, the usage of a Czech special spatial coverage code list, and we also needed to specify more precise terms of use that are compliant with the Czech legislation. So those are extensions. So we did localization, scoping, and extensions. And now let's have a look at some of the challenges that we faced. With localization, I already mentioned that it will be quite a tedious task to put the Czech labels to the global vocabularies. So the first challenge is where to actually put the Czech translations so that they are machine readable, that they are machine usable. And with this challenge, we also ran into an interesting thing. If you would please click on the slide. In our tool that we use, which actually machine processes vocabularies and different vocabularies, we wanted to use full homepage for something. And looking at that tool, we saw that full homepage has a description that says this axiom is needed so that Protégé, one of the tools for creating ontologies, loads DCAT-2 without errors. This is quite a strange description of a full homepage property. And it was because in that tool, we have also loaded not just full, but also DCAT. And in DCAT, there is a comment directly on the full homepage property that says exactly this. And therefore, we view this as a not so ideal way of annotating how a certain property should be used in a certain context. The next challenge that we faced was extension. So, for instance, we wanted to use Eurovoc for dataset themes, and there is an issue with DCAT-AP, which is linked from this slide. You can all have a look, and it is unclear at the moment whether this is actually allowed to use DCAT theme with something else than the 13 European dataset themes that are defined as a control vocabulary in DCAT-AP. So this is still unclear, but it seems like a reasonable thing to do, to take DCAT theme from DCAT itself and use different themes with it, but there is an issue. And then another challenge is with updates. We have DCAT, which has its versions, then we have DCAT-AP, which has even more versions. Then we have annexes to DCAT-AP, such as DCAT-AP high-value datasets, and all those artifacts are versioned. The changes in those versions should be propagated somehow through this hierarchy. So from DCAT maybe to DCAT-AP, to DCAT-AP Czech, to DCAT-AP HVD, and so on. And this is currently an issue because there is a human readable changelog. Maybe we have a colorful conceptual diagram like you can see here, which highlights what's new in the DCAT-2 adaptation into DCAT-AP Czech. This is not enough. We need a formal representation of what is actually inside of that data specification, and we need to use this to assist specification editors in their efforts in adapting to version changes of application profiles and reused vocabularies that are in the application profile hierarchy above their own current specification. So those are the challenges that we encountered. And now just maybe a hint, we are working on those challenges at a research group at Charles University, where we are developing currently an approach to specify in RDF what is a data specification with all its artifacts and all these insights. So what are the entity profiles, what are the reused vocabularies, and so on, with the intention of assisting or creating tooling to assist specification editors in with change propagation throughout the profile hierarchy, such as from DCAT to DCAT-AP to DCAT-AP Czech, and of course to also assist with consistency checking of the profile hierarchy. So this is it from my end.
Thank you very much, Jakub. Very nice and to the point presentation. We saw some challenges that you encountered, and you hinted at some solutions already. So let's move on then to Matthias. Matthias, do you want to expose the Swedish approach?
Yes, very much. And I would have also could have made a little bit of a similar presentation as Jakub did, because we've gone through a few of these different problems as well, even though we have different solutions perhaps. But I would like to talk about three things. First, I would like to present a little bit about our specification infrastructure we have in Sweden. Like we have actually, we can search for specifications in our data portal, and they're expressed in Prof, a variant of Prof SE. How we harvest them very briefly. And then also I would like to talk about the application profiles, even though that we don't have a enforcing everyone to do this in Sweden yet. We have a way of doing when we did it with DCAT-AP, also with Prof, a way of expressing formal expressions of application profiles. It's not standardized, but still we have something, and it's used for different purposes. That's what I want to say there. And then thirdly, I would like to talk about the plan we have for enriching the specification infrastructure we have, where we can look into these artifacts and try to understand them and make the data portal's view of these specifications more rich, like treating them like information models. So next slide. I will start with the specification infrastructure. So we are relying on profiles vocabulary that Peter Winstanley mentioned in the chat before. It's basically a way of expressing that we have this specification with metadata about the specification level. It's like DC terms standard or profile, I think it's the classes. And then you can describe artifacts or resource descriptions with some metadata as well. What kind of roles these artifacts plays in a larger specification. Like maybe you have a specification document, maybe it's a PDF or HTML, you have maybe an application profile, you have some UML, you have a diagram, you have classes and properties in the vocabulary, or some other material as well. So you see that you have dashed something here in red, and that's the things that we have plans for to enriching and formalizing. So that's in the end of the presentation, the last slides. Right, yes, so the harvesting mechanism for these Prof SE expressions are basically two right now. We have a national specification platform where anyone can log in and create their specification there. So they don't have to have their own tooling for agencies that are, you want to get started easily. But then those that are larger, like in the health sector or traffic sector or geodata sector, there are discussions of they have loads of specifications themselves, and those specifications should be nice to also show on the data portal of Sweden. So we need to support this harvesting step for those specifications, and preferably then we say it would be nice if we can express them in Prof SE. And that's actually we describe them as a data set with a distribution with a conforms to Prof, and say here it is as an RDF file, then you can load it into the portal. That's largely how it works. Next slide. So the result in the portal is that we have search interface, and just like we can search for data sets, you see there are like 3 tabs: data sets, data, and APIs, and then we have concept, which is in another discussion, and we have specifications. And whenever you have a specification, you can click on it, you get to a landing page, which we see on the right. We have some metadata on the level of the specification as a whole, and we see the artifacts or the resource descriptions there. Although I would like to point out that these resources now here are more or less black boxes. The only thing we can see at this point is the metadata about each artifact. Next slide. Now, okay, now I'm switching to what we are doing with application profiles. Of course, we can add an application profile as part of the Prof expression. It's just another artifact. But as I just said, it's a black box. It's not understood by the data portal. We have an expression, a formalized expression, but it's not standardized yet. We are relying on something called artiform templates. Yes, and we have some tooling for that to work with this. I mean, it could be seen as just a JSON file. You can edit them manually if you want to. But we have some tooling support where you can define classes and properties on the RDFS level as well, and then build on top of this using building the application profiles and also just defining them, reusing them, refining them, and extending them. And then we get some kind of UML-ish diagram. And this is the Entryscape platform I'm working on mostly. Next step, yes. So the formal expression we have for application profiles can be used for basically 4 different purposes. We can generate metadata forms for editing, and you see that is still on the left, where you're editing according to the application profile. There's no way you can generate something in that user interface that is not according to the application profile. But if you get metadata not from these kind of editing forms, but from other sources, which you get when you harvest, then you can use the same application profile to validate, and you can get some warnings. So that's very similar to how you get warnings with Shackle, although we generate something that is perhaps a little bit more form-oriented, so you can see where you've done something wrong. Then you can do a specification generation, like a web, a document, like in a PDF or on the web, from the application profile. And what we see here, and that's the one we have on the web, it's of course somewhere it's manually created, but it's the same source. So we have the same source for all of these 4 different parts. Actually, the web page you screenshotted and put there is on the fly generating, loading JSON files and generating this navigationable user interface. So when you update the template application profile, all of these different user interfaces changes. And that's the last part, the presentation. The data portal of Sweden, when you click yourself into like a landing page for a data set, the view, the metadata you see there are driven by the same JSON configuration, the application profile formalization. So changing one thing like adding HVD, high-value datasets, will show up on the data portal by changing one file. Next slide. Right, so now this is the future step. We need to break out these black boxes. We need to get out of these black boxes. So as I said already, we can find data sets, we can find concepts, we can find specifications. But right now, we cannot go into the individual classes or properties or the application profiles that actually the specification are built up of. Well, I would like to emphasize that not all specifications will actually be this richly defined. Some of them will be just a specification with a single artifact that points to a PDF file. And that's fine. They can be on that level. But if there are those that want to go further, that want to be more interoperable and enrich their specification, and maybe if they don't want to call it application profile, maybe its better name is information model. Well, we can dispute that, but still, we need a formal expression that we can open up and create landing pages for the application profile, the information model, click your way to the classes and the properties and see on those landing pages that, oh, this class is actually reused across different domains, across different agencies, which have slightly variations of the same class or slight variations of the same property. That's the goal, or the tentative goal, I would say. This is what we are working with. We have a working group that is looking into this. And yes, next slide. So the next steps, we need to find a more formal expression of application profiles in Shackle. So the expression we have right now, expressed in RDF form templates, is a little bit too specific to the tooling we have. We'd like to be more independent. So what will we need for this expression? It should still support validation. It should support the generation of specifications, like the specification document in HTML or like navigable user interfaces. That should be there. It would be very good if it had an extension mechanism, which several have mentioned already. Whether we can also, for the same expression, have edit and presentation support, is a bonus, but not necessarily something we should aim for right now. And I have been looking into, and I would be very glad to collaborate with others on this, like Jakub mentioned, they are already working on this, how to express this in Shackle. There are like the extension mechanism is a little bit tricky. Now, the last thing I would like to say, I think prof is very suitable for the style guide, for the way of describing semantic specifications and its artifacts. For instance, when you generate a specification document, you want to have a UML diagram at the top and then a lot of formal like reference stuff below. So it's not just Shackle, you need to have the diagram as well. So there are probably so that the specification document will be generated based on a prof-based specification and multiple artifacts inside of it that will together form how you can form this document. That's at least how we see it right now. And yeah, that's it. I think I'm done.
Thank you very much. We are remarkably on time, actually. Thank you to both of you, Matthias and Jakub. I am sure that these 2 presentations already sparked many ideas in the listeners' heads. Let's bear one more presentation. Let's also present the SEMIC approach to building application profiles. And then let's open up and discuss what we think about these three approaches. So I will give floor now to Csongor, my colleague, who will present the SEMIC approach to building application profiles.
Thank you, Eugen. As Natasha presented at the beginning of this webinar, we will talk about this blog article that we a lot of the discussion is about this blog article that we published in December, and the first part of the blog article was about the challenges that Eugen presented earlier, and we discussed about it, and the second part of that blog article is about one solution that we found by looking at this problem, and basically our focus was to align, to extend the recommendations in the SEMIC style guide that was published earlier or the end of last year, and the approach, our main approach in here basically follows the SEMIC style guide, which says we should start from a single source of truth. The single source of truth in our case, or what we recommended, would be a UML conceptual model. This is highlighted conceptual model. It's not just diagrams. Because from this the data specification artifacts can be generated, and so the idea is that vocabularies should mainly contain OWL or RDF statements, and application profile should mainly contain Checker. And in order to do this, we have to differentiate. In order to apply these principles to creating application profiles, we have to differentiate between an entity that is most of the time are defined in vocabularies, and the entity profile, which is the use of that entity in a certain context. So in an application profile, you are not defining a new entity usually. Sometimes you can, but the idea is you specify how a certain entity, and here by entity I mean both classes and properties. This is the OWL terminology that I'm using here. So how those entities that are defined in a vocabulary, how it is used or reused and used in certain context, in a certain application context, right? And and if you see here, I already show a screenshot of how this could be shown in UML. These boxes are actually classes in UML, and you can say that the vocabulary terms like DCAT catalog record and DCAT resource are classes, but they have a realization in a certain context. So that's the realization connector, which says, okay, this in the context, in the generic context of DCAT usage, a catalog record should have conforms to, or description, or issued and title, and these properties. These are already what we discovered by looking at DCAT and DCAT-AP, that actually DCAT comes with a default application profile, an implicit application profile. When you look at the UML diagram of DCAT, you see already how certain properties should be used. What are allowed and recommended properties to be used for a certain class. So what we did, we actually separated the vocabulary aspect of DCAT from the application aspect of the DCAT, the generic DCAT. I'm not talking about DCAT-AP here yet. So we okay. So and to do this, we realized that UML has the concept of UML profiles, which fits very well. And what we do here, if I go back, we use this stereotype, class application profile stereotype. By the way, very important that a very important aspect is the entity profiles will need to have a distinct URIs from the entities themselves. So what you see here, we can also, so we say that in the DCAT context, the DCAT catalog records, right? So and if I go here, I just show you that we use only two stereotypes, UML stereotypes. One is the class application profile, and the other is the property application profile. And the class application profile stereotype can be applied to any UML class. And the property application profile can be applied to the generalization, association, dependency, and attribute elements in UML. So that's what you can see here. And then basically, this approach also allows for the extensions on application profiles. So an application profile on the top of another application profile, and on top of another application profile. So you can use the generalization connector between class application profile elements. And what you see here is basically just a screenshot. I won't explain everything, but the idea here is that you have a default application profile of DCAT specifies certain uses of these properties, but you can extend this class application profile in DCAT-AP. And you can say that these are the recommended properties, and these are the optional properties, and these are the mandatory properties in DCAT-AP. So, and this is all in standard UML basically. And here, what we did is basically we modeled the DCAT, the full DCAT in two levels, at vocabulary levels and at default AP levels, what is provided by DCAT. And we modeled some of the DCAT AP, not the full DCAT AP, just to see that our idea is applicable and usable. And this is what we ended up with. This is a small screenshot of it, but of course we have much more information here encoded. It's basically a class in DCAT vocabulary. A catalog record has a primary topic, a resource. The cardinality is 1, but in the default DCAT AP, which is not, it's implicit, is not, it doesn't exist anywhere explicitly defined, or it's not published anywhere as such. Everything is included in the HTML page, but we separated them. So you have like a class application profile for catalog record, which is a realization of this catalog record, and the DCAT resource. And here the fourth primary topic is restricted to, it's optional basically, it's 0 or 1. However, in DCAT-AP, that extends this application profile, class application profile, and we say that the primary topic, the fourth primary topic, has exactly 1. The multiplicity is exactly 1. Okay, so basically you can go and further extend DCAT-AP in mobility DCAT-AP or in the Czech DCAT-AP, and you could say, okay, we have other restrictions on these classes or on these properties. In UML, an application profile will be defined as a package with this profile stereotype. You can provide your various diagrams that use these classes that you these application profile classes, and this is very simple. And for example, if someone would publish these models, these conceptual models for DCAT, then DCAT-AP could use already those classes and extend it. And if DCAT-AP would publish, for example, this model, if we would publish this model, then somebody who wants to extend DCAT-AP, they could just build on this. It would be that simple, and generate, and at the end you can generate automatically all the artifacts, the HTML, the diagrams, and everything. Okay, so regarding the tooling support, I just want to mention that UML profiles are part of the standard UML. We use only two elements of the UML profile modeling, basically the profile packages and the stereotypes, and we defined our own stereotypes, which are only two. There are other things that can be used, like metadata, tag values, and enumerations, but they are not required by our solution. And we actually published this reusable UML profile, so anybody can use that already. It's on GitHub. There is a link to that GitHub account, and it's also in the blog article. You can find it. And the only thing that needs to be extended, or the only difficulty, or not even difficulty, but the thing that needs to be done so that it can be used, is to extend tools that are generating automatically these artifacts. And actually it's not that difficult, because you can extend for example, the tools that we have easily to generate additional shackles. So the output of these will be shackle shapes. And here is just a quick overview of what are the pros and the cons of our solution. So, and I would just kind of read it. In our solution, we have this single source of truth, and that can generate all the artifacts. The generated artifacts will be fully in sync. They are nice diagrams. It's a principled modeling, so it's clear. So we do distinction between entities and entity profiles. We support logical consistency, so AP extensions are naturally supported, so APs over APs, and it's compatible with the current SEMIC style guide. And if people would like to adopt this, we can add the necessary additions to the style guide to describe this. And the disadvantages would be that the diagrams might become complicated, so you might need to split them up in multiple diagrams. The tooling generation artifacts needs to be extended. Free UML modeling tools needs to be evaluated. If this is a standard. The UML profiles are standard. It should be supported by all UML tools, but we have to see what is the practice. And you might need to do some remodeling for your existing models. But we did it for it. It wasn't that difficult, but it was actually a very fun exercise. So that's it from my side.
Thank you, Csongor. We are in time again. And I think now it's time to start the discussion about these three approaches. I think I noted a lot of overlaps between these three approaches, and I noted also that the challenges that they are addressing also overlap to a large extent. So who wants to start with comments or questions to our first speaker?
I think Rita is commenting, so maybe it's easier to comment in words, Rita, than to type it all out.
Rita, please.
Yes, okay. So I think that when you say that the stereotypes can be is on the top level and everything can be derived from them, I think that in that sense, yeah, they are very similar to ontologies. And for example, all in that sense that you can say in all that everything can be inherited from all thing that itself doesn't contain anything. So that I think that in that sense, you can create ontologies from your UML stereotypes. But I think that that's okay. But if you already are using the ontologies, so in that sense, you don't need stereotypes because you can start from the next part of the process, so to say.
Can I just respond to this? So so the interesting thing is that if you observe between the vocabulary and the application profile, the relationship is not a specialization. We are not creating a subclass. We are creating a realization. So a use, we say how it is used. So of course you can express that also in OWL, but it wouldn't be a subclass. So that's what I want to underline, and also that we will actually generate checker shapes out of these class application profiles and the property application profiles. We are not generating classes, so we are not inventing new classes. The target of those checker shapes will be the original class. So it will be, you understand?
Yes, because I think that we are also making ontologies, but we from them we make application profiles, and they are in shackle shape. They are shackle shape, so that I think that in principle the principles are the same, but the actual implementation and technological tools are different.
Yeah, definitely you can do it also in OWL.
Yes.
So
anyone else? So
maybe, yes, Matthias.
So the question I posted in the chat was that the inheritance between two application profiles, like for a data set, would you need to, what does it mean? If you have listed on the DCAT level that you have a DCAT theme, and now you're going to change that and you want to restrict the DCAT theme to the range is something specific or a specific cardinality. Will it be inherited and you don't have to say something, or you will have to say it because you want to override it? So what is the mechanism that you have envisioned here?
Can I comment on that? Very good question. And in fact, yes, if you in shackle, you can extend shackle shapes. They can extend in one another. And what's also very interesting in shackle shapes is that you have a mechanism. So the standard foresees there's a mechanism by which you can disable some of the inherited constraints. So the child can say, I don't want to use some of the parents' constraints. So that's a nice mechanism, I think, to use sometimes when we have to define non-compatible extensions. So that would work. But
I'm aware of that mechanism, but that's not my question. My question is about how the semantics of the UML approach you've taken. What do you think it means to have an inheritance between two entity profiles, so to speak?
So let me add that actually we can define the semantics. So in UML it allows you to graphically represent these things, but the semantics, how we will translate that into the artifacts, into the shackle and OWL, I think UML doesn't provide us semantics. The semantics we will define we can define it in the specific in the style guide, right? So this is how we will interpret it, right? And then all the tools who want to implement that would follow that. And one example, I mean, what Eugen said, that could be the interpretation, that's the semantic that we attach to that.
Okay, thank you. I just want to point out that I think the discussion we had before, that we would probably need two different kind of extensions. When you want to inherit the properties, and when you just want to overwrite them, this is the ones I want to have on my. And then the question is, do you really want to do an inheritance between DCAT and DCAT-AP at all, or should you just directly instantiate, or whatever it's called, from the class instead? But the shackle is that's a very interesting discussion as well, Eugenio. Different but interesting.
What I can bring here, maybe it was implicit in my mind, but I make it explicit. So indeed, UML per se, unfortunately, the semantics defined in UML language, it's not applicable to us. So what we had to do before building any tool is to define, and anyone that actually builds a tool for this purpose will have to define a set of UML conventions. So that's how we call them, UML conventions, which precisely, or formally in fact, define each UML element, how it will be transformed into either OWL or shackle, or what will be the meaning of a specific relationship. That's what you just asked, Matthias. So indeed, we can't write any tool without formally defining or redefining the UML, the meaning, of those UML elements. And that's what we've done, in fact.
And can I add something, that you are always free to start with the vocabulary class. So that's also an option, right? And also I wanted to say that maybe you pointed out that we might want to specialize. Maybe we want to specialize this relationship and say that this is an overwriting thing, or you know. But that's probably complicates things, but it's possible to add the stereotype on this. Like what is the extension type between these, okay?
Tongo, can you go back to the overview of it? Short comment from my side. I think what is visible here, and what we have to indeed to find out together with you, is what is, let's say, realization means, how we see this in implementation wise and expectation. Does it mean covers everything and so on? But there's an aspect on which is orthogonal to it, in the sense of, if you have a vocabulary, you see at the top level a vocabulary, and you say, I'm realizing it in an application profile. A vocabulary is a very loose collection of terms. So does that mean that if I'm realizing an application profile based on the vocabulary DCAT, that I must use all the URIs that are inside this vocabulary or not? So this is a bit of the expectation, what it means. And I think we have, a vocabulary has a different life cycle and a different evolution rather than the application profile. And then this, maybe we have to disambiguate this better between amongst ourselves. And just as a note, and this is the reason why this picture is shown as well, and it's where that Songo maybe struggled on the cardinality, is that in the DCAT2 TTL file, there is on the fourth primary topic a mandatory 1, where in the text it is optional with max 1. It's functional. So it is just to indicate that if you do it manually and you don't make it aligned, then you might end up in these differences between vocabulary and application profile, just as an indication. So this is an outcome of our exercise. And then the question that Alberto asks, how you create a specification, human readable specification from a UML source. What you have to understand is that the UML source is not just the drawing, but the whole collection of information that is behind the drawing. So the drawing it is not just an SVG of a PNG that you see, but it's the whole collection, the arrows, they are meaningful. So there's a meaningful source, and therefore you can derive information from it.
And it has tags and descriptions and everything. You can put all the information that you want in your HTML to appear. You can encode it, and actually that's what we are doing, right? In many cases.
But even with that, you have to parse it.
DCAT-AP. Sorry.
You have to parse it. Yes, indeed, Alberto. So this is the thing, the activity. There you have the XMI standardized format, which you can explore and evolve and use to extract all the information you needed. That's the full content of that UML model. That's what we refer with UML model to. It's not a diagram, the drawing, it is the whole information associated with it.
Hand raised, Geert.
Geert, or no, not anymore? Anyone other hands raised?
Sorry.
Yeah.
Sorry, I was speaking without when I was muted. Just to say that we use the stereotypes and UML profiles for implementation models, not for creating different application profiles on the same vocabulary. For example, we use it to override, for example, a semantic cardinality. Semantic meaning that in reality this property always is there, but in implementation there's for example no need to exchange this property. And so to separate let's say the functional aspects from the semantic aspects, but indeed we do not have a mechanism to formalize it, which would be very useful indeed for implementation models, at least to be able to formalize it, maybe in Shackle or some other way. And another thing I want to say is because everybody thinks, you can't use UML diagrams as a single source of truth because they are graphical. I just added a comment in the chat that there is a formal language to describe these diagrams, which is called XME. So it would be possible to extract the stereotype information from the XME. Although I never tried this or never studied this aspect, but it would be a possibility, I think.
It's interesting that you bring it up because indeed UML is being perceived as just a diagramming, medium, but not a way to express conceptual models. And that's not the case. We can express conceptual models provided that we have a precise set of conventions to know what they mean, because that's a drawback of UML. You can express the same thing in multiple ways, and it has to be agreed how and what it means. Yeah.
Well, it's not always the case. Well, the problem is people think that there are different meanings behind all the graphical symbols, but if you look in the UML specifications, the problem is that not everybody knows what is exactly meant by the graphical things and connectors and so on, but they are rather formally specified in the UML specification. So it's rather a problem of not knowing what's in the specification than it's a problem of the possibility to interpret it in different ways. My experience, if you look into the specifications, is that it's rather strict, all these connectors and all these Everybody always says, "Oh yeah, UML you can interpret it in different ways," but I don't think so. It's rather stricter than you think.
Let me correct myself then. I didn't mean interpret, but represent. The same thing can be expressed in multiple ways, right? So then if you want
of course,
if you want to
for
write
example, a class or a data type and that kind of thing, although there's also a definition behind this difference between the two.
Correct. And there's another very interesting thing is that from my experience doing some modeling and showing these models to people, to a working group, right? A group of experts. The moment when we start talking about logical axioms, I lost everyone. Or like formal class definitions, not formal, but like doing a glossary and then having definitions of concepts and properties. But when we show something visual to people and ask them, is that what you meant? Do they relate in that way? Or then people have a completely different reactions, and they comprehend. It's much easier to comprehend, even for non-technical people, to understand this graphical representation. So doing, let's say, conceptual modeling with a visual language, at least from my personal experience, but some other people share probably this, was much easier to create consensus yeah.
Thank you, Jean. I think we have to close that now because we want to move on to the next, which is the discussion about what if the UML is replaced with another single source of truth, and what should that take form? So this is the next part of the further discussion.
Yes, let's run through this. The RDF-based, let's go back just one slide. It's about the RDF-based conceptual models. It's something that some of you brought up, that the single source of truth can be other than UML. And we want to write next a blog article about this and to explore what are the other possible single sources of truth. Let's move on to the next slide, please. And let's see basically a set of prerequisites for it, and then let's see where it can be taken further. So just to reiterate the main ideas that are presented in the style guide, is that, I will repeat, data specification comprises multiple artifacts and they have different purposes. So mainly either to define a common vocabulary, and probably when it comes to vocabularies, it should be just vocabulary, no constraints, and specify data shape constraints, and that should be just specifying constraints, not extending towards defining new vocabularies, new terms, sorry. And so we have to accept a purpose. Then we have to accept the fact that one data specification comprises multiple artifacts, and then each artifact addresses a concern. And this idea of concerns is very important because we know why an artifact is there, and what we know whether it fits the purpose or not. And last, and the very important one, they must be coherent between each other. Let's move on. Next slide. So there are two contexts that I will present. There's the consumer context, and next, later on, I will present the editorial context. And in the consumer context, the need is to bring the domain experts closer to developers who will implement certain systems, certain information systems. And when domain experts interact with those systems, they need to recognize the same concepts that they speak with other domain experts, right? So we need to make this communication as smooth as possible. The idea is to bring a data specification which is understandable both by domain experts, developers, and machines. Whatever understandable means for machines, it's a different discussion. Next slide, please. And the concerns, if we follow the European interoperability framework, there are 4 layers of interoperability. I highlight here 2 of them, the semantic layer and the technical layer, because it's very often the 2 are conflated. And I think it's useful to distinguish the concerns that are in the semantic layer and the technical layer. I will focus here only on the semantic layer concerns that need to be addressed by a data specification, but we plan on extending and seeing how we can write data specification which can address also technical layer concerns. So for the semantic layer, I think we need to ensure that people can visually see the domain model, that there is a domain model to begin with. There is a conceptual model. We have a very clear definition, both formal, means we have URIs for each term, and informal, we have human understandable labels and definitions. We know how to put this model into practice. We know how to instantiate it. And we can hand over to either to a business domain expert or to a developer a human readable document, which is clear, complete, and precise. So I think these are the minimal set of concerns that we need to address when we are designing or when we are choosing a single source of truth, to enable generation of artifacts for these purposes. Let's move on. And then in the editorial context, so when we are creating this data specification, first, we need to make sure that all the artifacts are coherent. We can easily maintain across all of them without making mistakes. And we can ensure high quality when we publish this data specification. So the solution is using a single source of truth and generating automatically the rest. Let's move on. And here we have been proposing to use UML as a conceptual model. We have shown that it works, and we can that it works, but it's not the only language that can serve as a single source of truth. And today we heard at least 2 examples. Someone is maintaining single source of truth in JSON. Someone is doing it in a variant of OWL or OWL. And then the question here is, if we would move away from UML, we don't need to, but if we would move away, what would be, a viable alternative? And that's I would like to start this discussion here because next we want to include all this feedback that you will provide us either here in the discussion or later on via GitHub issues or via email, because we want as much as possible to consider before we write this blog article. So let's but before we move to the discussion, let's go to Slido, please. We have 5 questions prepared for you. So we would like to get your feedback on these 5 questions, and then we will have a discussion. So if you can scan this QR code with your phones, please. It will take you to the Slido questionnaire. And we should have our first question. Let's give it a minute. So the first question is, it's not shown on the webs here, but yeah, thank you. What do you use to express the single source of truth? Which languages? Okay, let's move on to the next question, perhaps. And the second question is about the set of concerns that you are addressing, and whether the ones that we have listed are sufficient and necessary, or you maybe have additional ones, or maybe you don't need to address all of them. And the next question is about which tools do you use for managing and editing the data specifications? No tools, or there are some, maybe you develop something by yourself or someone else. Perhaps you may find some commercial tools suitable for your purpose. What do you use? Okay. Question number 4 is about how does this style guide and this webinar and the style guide, how do they serve you? Basically, why are you here? To stay informed or to get answers? Maybe you have some open questions that you need answers to, or you want to raise awareness about something that it's not yet addressed, or you want to contribute. Yeah, align. Tell us what brings you here, so we know how to serve your needs best. And question number 5 is, in case you have some in case you need to go for answers somewhere to get, where do you go with regards to modeling questions? So do you use some forums, do you use some communities, or such as, I don't know, what organizations or forums, or maybe social media? Do you use social media? Yeah, which platforms do you turn to? Right. Let's wait 20 more seconds. And we can start the discussions. I see Bert is pretty popular.
Yeah, that's not a proper answer, of course.
Bert is the SEMIC's bard, you know.
No. Okay, fun enough on that. I think it's indeed good to look and so what it brings this. So the reason why we ask these things as well for this, in particular the last one, is to know who to reach out, who to bring together, and to know if we can enlarge or can do some maturity aspects on the community. To bring people more together in this area, because we know that on a topic such abstract as how to model things and what are the guidelines, there are not so many opportunities or places. So we would like to see if you are aware or you have some backup at your member states or nearby colleagues and bring them together. So this is the idea behind that question. Nevertheless, so coming back to our main question, that's on this last part, to short open the discussion and give you a possibility to give now live feedback to what are certain characteristics that we should take into account for an alternative single source of truth. Normally and preferably RDF based, let's focus on that. But what does that mean? RDF based single source of truth. What should it contain and what is it? Do you have any additional points that we have to take into account here?
Maybe we can hint that if we are to design or to create or to decide on what would be a good RDF-based language for expressing conceptual models, we should probably consider something, a combination of several languages or several vocabularies, such as OWL, Shackle, maybe Prof, Matthias recommended, in order to be able to address different needs or concerns that this single source of truth needs to fulfill in order to serve the concerns of all the artifacts, right? So
for instance, we saw the localization challenge that Jakub raised. So how to deal with that? How does that, can this RDF single source of truth deal with localization? Yes or no? These kind of challenges we will consider, but are there any advices that you would say what would be a good basis for the future?
So I can maybe ask a question. We saw that the visual representation is useful. I think most of us agree that the visual representation is useful. There are initiatives to generate visualizations from OWL ontologies, but those visualizations have one shortcoming, is that they are not stable, because there's the position of boxes and lines, they will not, they will be floating, right? So this need for stable diagrams, for example, is it a strong need on your side, or you don't feel the need to have this? And I know Rita, for example, she said that they're using OWL as a single source of truth, or the starting point. Rita, do you mind commenting if you feel the need for the visual representation as well?
Well, yes, we do have a visual representation.
And how do you go about that?
Well, it's so that we have sort of a visual editor, so that when we are creating a class, then it shows the visualization on the right hand side of the screen, and we can move the boxes as we like and draw lines, and then we save their coordinates, and after that we have visual presentation. So that is that we have the data model, and then we create serializations and visualizations from that data model.
And so I hear that you have already a solution, a tool that allows you to create visually. So when you edit, you create first, you mostly interact in a visual manner with it. You don't write the OWL classes directly.
Well, no, yes. The point is that we have OWL, but in principle we have a form that we fill in that form that, for example, create the class, and if it's a subclass of some specific OWL class, or when we are doing application profiles, then we have a what is the OWL class that is the source, so to say, what target of that application profile class. And so we have a template or form, and we fill the information about the class there, and then the tool draws that class as a box and visualize them, and we can move those coordinates of the boxes, so that in that sense we have on our tool, and it takes care of it's one single source of truth, and we can create different kind of presentations from that.
And do you?
The question, Rita, do you version your visualizations, your statuses? So like we have, so one of the topics that was raised as well was you have DCAT-1, DCAT-2, DCAT-3, DCAT-AP and so on. We have many versions. Do you have, can you put the versions next to each other as well?
Well, not next each other, but we do have versions, because we had an old version of that tool, but we have now created a new version of that, and in that tool we are able to create different versions, so that, for example, we have data model described in version 2.0, and then we have other data model that describes the version 3.0.
Okay, thank you. And is there anything that we can learn as saying what is information that you store inside that model to keep the versioning coherent? Because you talk about the same class in the same in the different versions, but they are distinct constraints.
Yes, the point is that the data models have same URI or IRI, but you can specify what version of that data model you are targeting, so that they have the same URI, but you can specify which version of that data model you want to use. So that, for example, when we create links between the data models, and there will be a new version of the data model, you can then either keep the old linking or change the link to the new latest version. So.
Okay, thank you. But I would certainly I think it's good that we have a look or share your expertise based on what we can build.
Yes.
I saw a comment from Alberto that on the representation side of this single source of truth, saying RDF is nice, but maybe better a YAML or a JSON representation. So for us, in first place, this is an exercise to get the semantics right, the content of this RDF model, and it should be possible to create a comparable other serialization for that, if we would like and need it. So this is, I think this is more serialization or technical serialization issue rather than a semantical issue.
I don't agree much, but because for many use cases, not for all, I agree, you can have all the semantic information that you need. And the main point for this is that if you want to recruit people, I don't know if this is your case, but we struggle to find out RDF qualified people, while YAML and JSON schema, they say it's not that easy, but it's easier than RDF.
I think this is, let's say, on a technical readability, this is true. But is the problem not going away? It is either JSON or either RDF. Is that not the same challenge that we are addressing for you?
No, for us it's a bit simpler, but there is another point that I want to make, is that when you try to make these models to be adopted by the user, by industry, if you start talking about RDF, which usually is not in their catalog of knowledge, then it is very, very tough, quite tough. So if you go to something which is from their mindset simpler, like JSON schema or YAML, then the discussion and the dialogue could happen. Otherwise, in our experience, I know it's a very particular case. For others, could be completely different. But if you start with RDF, they say, oh, this is not my business.
And but Alberto, just a question. I think we are, in terms of, let's say, the focus here is on the JSON schema language that you use to generate your JSON's expressions of. That is the alternative. We're looking for a language, an RDF language, to represent the JSON schema. And all the constraints that are associated with it. That's where the alternative is.
Maybe no, I didn't find out, because inheritance, especially with JSON schema, is not as powerful with RDF. So that's why I'm saying it's not always possible to use it.
Yeah. But this is the area where we are looking at. So the single source of truth is the JSON schema in your example case that you highlighted. I know. And I want, given the time, I want to give Vasilis the words. I think as a last, we has mentioned several comments.
And Pascal has his hand raised.
Pascal, then, but well, first Vasilis maybe, and then Pascal to conclude.
Okay, thank you, Bert. It feels like in any niche webinar we make the same discussion about UML and RDF and what's the single source of origin. So we never said that we don't like UML, but we said that the SSO should be the RDF and then transform to UML and make the diagram. Why this is not possible? The opposite creates some problems because the UML has different semantics, and DCAT-AP and all the vocabularies we are talking about, these are RDF-based vocabularies. They are not UML-based vocabularies. So we should start from RDF, so we have the full semantics. Okay, I know that now we all want to have light ontologies and so on, but there might be cases that we want to use the extra semantics that our RDF is providing. So why not having, why not starting from our RDF plus SACL and then transform to UML and use the nice diagrams that UML is providing. And we all agree that this is necessary because people is understanding better these UML diagrams and so on. That is my comment.
Yeah, so for this is the route that we are going to explore. So happy to have your contributions in there. But one of the challenges that we observe already, and that's the reason why we started with the challenges, is that there are many, let's say, things, and let's note what I gave it in RDF, and you think you have full freedom. And if everybody takes its own full freedom, we cannot combine and reuse from each other. So it means we have to restrict ourselves in the full freedom in order to help your colleague, your potential reuser, in a way that it is easy. And if we make, for everyone makes its own reuse potential, then we end up in things that we cannot reuse because A and B are not compatible reuse strategies. And so this is the thing where we want to discuss about it, that we can express the single source of truth in RDF, one, And then in combination with that, see that we can apply rules on that single source of truth so that reuse can be realized. And this is a challenge. So it means we have to limit our way of working to a certain extent.
So I think, Bert, reuse, it's important, yes, and being able to derive other artifacts and be able to publish the data specification with all different artifacts, that's also important. Yeah.
And so we have to combine, and so this is the goal. So let's try it now with you all and to get the feedback, a good feedback. What does this RDF information should contain? What is this single source of truth information should contain, so that we don't miss anything?
Or rather, if we think about it a bit more abstract, it's like a conceptual language, and the question is, what sort of things should this language express so that everything can be derived from it? Pascal, you want to take the floor? You have your hand raised.
Yes, I will give my feedback. So I am in a position where I have to publish the draft version of the DCAT application profile. And let's say I'm a newcomer. So I've got a huge experience in UML, but I can tell you now that I'm diving into RDF, UML is probably not the right way to express an application profile. I will say, let's go for RDF. And if I can reflect what I'm doing now, because I've got the deliverable for the European Commission for one project, the draft version of the DCAT application profile, what I'm doing now is using GitHub, respect, and what I would like to do is to provide the access to the draft application profile from an API. So really providing the stakeholders the possibility to read what it is exactly this application profile with several serialization, JSON LD, turtle, and being able really to give the essence of what is the application profile. Of course, I'm going to publish UML diagram, but to my point of view, when I see the different stakeholders, they are non-experts. So here I will prefer to give in their hands editor, and this is what we are building, a DCAT application editor, and also an API for the experts, so they can read the application profile as a RDF source.
Thanks a lot.
I don't know if you have comments about the approach. Of course, doing this, I will have some feedback. But first of all, what I think it's very important in all situations is to rely on the best practices. It's the reason why I'm investigating in respect, because we need to do like the others in a way, and also looking at what is exactly the best solution. UML, to my point of view, what I'm doing now is not the right solution, even if I'm going to publish UML diagram using UML class diagram using Draw.io. But for this type of activity, link data, it should be RDF to my point of view. And I'm stopping there.
Maybe a short comment from my side, and then I give floor to Csongor. I think you highlight a very good part, is that when you publish, right? When you publish, you want to publish in different representations so that each representation fulfills a different purpose, right? Or a different need. You mentioned JSON LD, you mentioned Turtle, you mentioned HTML, respec, right? Respec. And may I ask you, what do you use as a single source of truth? Do you edit them separately, or do you use something central from which then you derive the others, or you edit RDF and maybe OWL or shackle, and then you edit the HTML separately.
I have not consolidated one solution. I don't know.
Because what we're trying to arrive at, you know, kind of consensus, how to have like only one central place where we write everything we need to write. And then from there, we generate different representations automatically. You know, so you don't need to do multiple editings in each artifact.
Yeah, I do understand, but I don't have a solution.
Yeah. So
also, why I'm there, looking at how to do it.
Yeah, so there are such solutions, and we're trying to arrive at consensus how to do it. Yeah, Csongor, do you want to comment? And Matthias, yes. I don't know if we have much time, actually.
Yeah, that's what I want to say. We are over time, so I think it's to wrap up. But we saw indeed the comment from Matthias. There are indeed existing solutions. We will take them into consideration. We will reach out to you. But if you have aspects and that you want to raise in this topic, so your experience, say, okay, this is a valuable addition that made our tool or our approach work, please share it, or if you're willing to share it, of course, so that we can continue on it. If you have, you know, our contact details. If not, you can always reach out to the GitHub of the SEMIC Style Guide.
Next slide, please. It's the contact slide.
Yeah.
Still have to present next steps.
Okay, good. Natasha, you would do the wrap up.
Okay, I will do the wrap up. Okay, I will say one thing before doing the wrap up. Just that we don't underestimate the power of RDF all plus SACL, but maybe we need to emphasize one more that the thing here is to try to provide a consolidated solution that gathers all the information from the different artifacts and then create the different artifacts, as we say. So even the scope notes are very much important, and we cannot have them in every specification, or we need to have to find a way to combine all artifacts. And this is why we are doing all this. And we are not trying to, let's say, impose UML as the single source of truth. So that being said, let's try to work on it and find a solution. And as for the next step, we are going to collect feedback on what we discussed today. So how do we work with application profile development? And also our new, let's say, focus will be on the RDF-based conceptual modeling. Conceptual model or conceptual modeling language, we have to see how we're going to specify this. So please come back to us with more ideas and problems. You know how to do this. We have a dedicated space in GitHub for the style guide where you can post issues there and we can iterate discussions. We are planning also, after collecting your feedback and maybe co-working with you on it, we will publish another blog article on the RDF-based conceptual modeling language. Next will come a new and updated version of the SEMIC Core Vocabulary Handbook. And based on all the feedback that we will collect until end of April, let's say, or May, we'll see, on the application profile development and on the RDF-based conceptual modeling language, we are going to have a new release of the style guide where we plan to include this feedback. So these are our planned next steps. Thank you very much for joining the webinar. Thank you very much for your contributions. A big thanks to all the speakers, and thank you for the extra time.
Thank you for a very interesting seminar.
Thank you very much.
Looking forward to your further feedback. So please come back to us. Have a good day.
Okay. Bye.
Bye.